you've built up to impedance and the phase angle. Now let's talk about power and why that phase angle actually costs money. In AC, power isn't as simple as watts. Because of reactance, there are really three kinds of power. Understanding them gives you one of the most useful numbers in the trade, the power factor. Here's the root of it. With reactance, the voltage and current fall out of step by that same angle theta. When current lags or leads the voltage, part of the energy just sloshes back and forth without doing any work. So the source ends up supplying more power than actually gets used. To handle that, we split AC power into three pieces. First, real power, P, the actual work, heat, light, motion, measured in watts, and it's what the resistor uses. Second, reactive power, Q, the part that sloshes in and out of the coils and caps, doing no real work, measured in VAR. Third, apparent power, S, the total the source must supply, voltage times current, measured in VA, and these three form a right triangle, the power triangle. Here's the beautiful part. The power triangle is the exact same shape as the impedance triangle, same angle theta. Power factor is the ratio of real power to apparent power, P over S, the fraction that actually does work. And that ratio is simply the cosine of theta. Power factor equals P over S equals cosine theta. It runs from 0 to 1, where 1 is perfect. And notice it also equals R over Z. Let's put numbers on it using our RL circuit from last time. Recall, 100 volts R is 30 ohms, XL is 40 ohms, so the current is 2 amps. Real power P equals I squared R, 2 squared times 30, 120 watts. Reactive Q equals I squared X, 160 VAR. And apparent S equals V times I, 200 VA. So the power factor is P over S, 120 over 200, which is 0.6. That matches cosine 53 degrees and R over Z. Now, why does a low power factor cost you? A low power factor means the source has to supply far more VA than the watts you actually use. For the same real work, you pull more current. Take 960 watts at 120 volts. At a power factor of 1, that's 8 amps. But at 0.8, you need 10 amps for the very same work. More current means bigger wires and more loss. That's why utilities build large customers for a low power factor. Let's recap. AC has three powers: real P in watts, reactive Q in VAR, and apparent S in VA on the power triangle. Power factor is P over S, which equals cosine theta, running from 0 to 1. Keep it high, close to 1, so the source isn't wasting current moving power that does no work. Next time, power factor correction. Add in capacitors to cancel the reacts, and push that number back toward 1. See you at the board.